Hello everyone, in today's lecture we will be discussing the MRU page replacement algorithm. If you would like to learn about other page replacement algorithm, please visit my YouTube channel for more tutorials. So MRU stands for most recently used page replacement algorithm. In MRU, the page that was most recently used is replaced first, and this page replacement algorithm is opposite to the least recently used algorithm. In MRU, it's going to assume the page used very recently may not be needed again immediately. This approach works well in some certain situations where older pages are more likely to be reused. Here we'll go through this example. This is a page reference string and the number of frames are 3. For this example, we are going to apply the most recently used page replacement algorithm. So initially the number of frames are 3. So initially all the 3 frames are empty, and the CPU it will request the first page, that is a 5. It is going to search it in the memory. 5 is not available. All the 3 frames are empty. 5 is not available. So that 5 is leading to the page fault. Next we have a reference string 0. So 0 it will search it in the memory. Only 5 is there. 2 pre-empty spaces are there. So 0 is not available. Again 0 is leading to the page fault. The next requested string is page string is 1. So it will search it in the memory. 5 0 1 empty spaces. So 1 is not available. So 1 is also leading to the page fault. Next requested page is 0. Again it will search it in the memory. 501. So 0 is already there. So if the 0 is there, then that leads to the page fault. So next reference string is 2. It will search it in the memory. 501. So 2 is not available. So as per the MRU page replacement, so most recently used page is 0. So that is to be replaced by 2 now. So 5 and 0 is replaced by 2 and 1. So 5 to 1. So again this is going to be a page fault. Next, see here we have the next requested page is 3. So it will search it in the memory. 5 to 1. So 3 is not there in the memory, and the most recently used page is 2, and that is to be replaced by 3. So 5 and 2 is the most recently used page, that is replaced by 3. So that is also leading to the page fault. Next reference string is 0. It will search it in the memory. 0 is not available. So the most recently used page is 3. That 3 is replaced by 0. So 0 is also leading to the page fault. Next we have a 2. 2 requested page string. Now it will search it in the memory. 501. 2 is not available. So the most recently used page is 0. Now so most recently used page is 0. Now it is to be replaced by 2. So the 2 is also leading to the page fault. Next requested string is 4. It will search it in the memory. 4 is not available, and the most recently used page is 2, and this 2 is replaced by 4. 5 4 1, that is also leading to the page fault. Next requested page is 3. It will search it in the memory. So 3 is not available, and the most recently used page is 4. That 4 is replaced by 3, and 3 is also going to be produce the fault. Next requested page is 3. It will search it in the memory. So 3 is already available, that is leading to the page hit. Next requested string is 2. It will search it in the memory. 531 only available, 2 is not available. So as per the most recently page replacement algorithm, and 3 is recently used, that 3 is replaced by 2, that is also going to be form a page fault. Next requested bit is 0, and it will search it in the memory. 521, 0 is not available. So most recently used page is 2, and this 2 is replaced by 0. So 501, that is also producing page fault. Next requested page is 2, and it will search it in the memory. So 501, 2 is not available. So that is also leading to the page fault, and the most recently used page is 0. That 0 is replaced by 2. So 2 is also leading to the page fault. Next requested page is 1. It will search it in the memory. 5 to 1. 2 is already there in the memory. So 1 is leading to the page hit. Next I have page 2, that is CPU is requesting the page 2. Then it will search it in the memory. 5 to 1. 2 is already available in the memory. Then so that is also leading to the page hit. Next we have a reference string 7. It will search it in the memory. 521, 7 is not available, and the most recently used page is 2. That 2 is replaced by 7. That is 7 is leading to the page fault. Next reference string is 0. It will search it in the memory. That 0 is not present in the memory, and the most recently used page is 7. That 7 is replaced by 0, and 0 is also going to produce the fault. Next we have a reference string 1. It will search it in the memory. So 1 is already there in the memory, then that is also going to produce the page hit. Next we have a reference string 1. It will search it in the memory. So 501, 1 is already available, that is also going to produce the page hit. So we'll count the total number of page fault and the total number of page hit. So and the total number of page faults are 14 and the total number of page hits are 6, and the hit ratio will be calculated now. And the faults also should be calculated. Here the hit ratio is equal to the number of page hits divided by the total references. The page hits are 6 divided by 20, and the fault ratio equal to the page fault divided by the total references, 14 by 20. And so there are some advantages of most recently used page replacement algorithm. This page replacement algorithm that is used in some specific applications like database systems and sequential file access, and it can also perform better than LRU in some certain access patterns. And there is a one disadvantage that usually it performs worse than the least recently used. For a general purpose system, recently used pages are more often needed again soon, and it can increases the page fault in normal workload. Okay, so this is all about the difference between the MRU and the LRU page replacement algorithm. Next here we have one practice example. This is a reference string and the number of 3 frames are given, and you have to calculate the hit ratio and the fault ratio for the given practice example and write your answers in the comments. Thanks for watching my videos. Don't forget to like, share and subscribe my YouTube channel. Hit the bell icon so you never miss my upcoming videos. Thank you.